The last one was
Okay.
for the present.
You did a warm up using, you did a warm up on personal composition and molar mass. Is that correct? That is page 17. Is that right? The back of page 17 is blank, correct? Can you all go to the back of page 17? Can everybody go to the back of page 17? And we're going to take some notes down. All right? So, there is a solution on the back of your warm-up. Write these things down. Write solution, and then write solute, and then solvent. So say I mix salt with water. Can somebody tell me what is the solute, what is the solvent? Yes. Water is the solvent, right? Example. So example, salt plus water. Is that right? What is the solvent? Water is the solvent. And what is the solute? Salt is the solute. Or in other words, when we do solutions, all right, the part that is lesser, solute is the lesser part.
Okay, what?
When we take salt water, isn't salt lesser in amount than water?
Yeah.
So the one that's lesser in amount is called the solute.
Oh.
The one that is more in amount, the one more in amount is called the solvent. Now, when you mix salt with water and make a solution, is it an element, compound, homogeneous, or heterogeneous mixture? What is salt water? It's a homogeneous mixture, all right? Solutions are always homogeneous mixtures. Now, should a solution always be a liquid? Solutions can be solids, solutions can be liquids, and solutions can be gases. So, can somebody give me one more example of liquid solution? I did salt water. Give me one more example. Sugar water. So any sugar drink, any type of soda or anything that you drink is a sugar drink. Is that right? So soda, all these are examples of liquid solutions. Can somebody give me an example of a solution that's a gas?
Fart.
Oxygen is an element. It's on the periodic table.
Fart.
Fart, actually not bad, is a gaseous mixture. But I don't want to write fart. Give me some other everyday example. Yes. Air. Air is an example
Hydrogen.
of what will be the solute, what will be the solvent in air. What do we have more of in air? What is oxygen? Solute or solvent? Oxygen is the solute. What is the solvent in air? Nitrogen is the solvent. Give me an example of a solid solution. Rocks are generally heterogeneous mixtures. And they can be pure compounds also. Cloud is just water condensed. Diamond is an element, carbon, pure carbon. A homogeneous mixture. Give me a solid homogeneous mixture. Coal? Coal is pure carbon. Ice is water, it's a compound. Rock, we said, are generally heterogeneous mixtures. Have you heard of alloys?
No.
Have you heard of 18 karat gold?
That's what I got.
All right. So what does 18 karat gold contain? What is the solvent?
Silver and gold.
Silver and gold. So what is the solvent? In 18 karat gold, what is the solvent?
Gold.
Solvent is gold. And what is the solute? Silver. Is silver. Alright? Silver is in lesser amount, gold is in more amount.
Would we have anything that says?
Well, you should know solution.
So, but how we know like if which one is the salt and which one is the
Not exactly. That is an extension. Okay?
Okay.
You should know in general, if you make solutions with water, what is the solvent? Water is a universal solvent, right?
Water.
Okay. Now, when we make solutions, say I'm mixing salt with water. Alright? I can make 3 types of solutions. What are the 3 types of solutions I can make with salt and water? I can make a unsaturated. I can make, this is important, I can make an unsaturated, a saturated, and a supersaturated solution. What is the difference between the 3? What is an unsaturated solution? What is a saturated solution? What is a supersaturated solution? Yes. Well, no, it's fully mixed. Otherwise, it's not a homogeneous mixture. It can be a solution. So, I'm taking salt and I'm adding it to water. What makes the solution an unsaturated solution? Stephanie, are you with me? Are you listening? Yes. Very good. When there is less salt, then can be added. Or, I can add more salt and dissolve it. Is that right? If I can add more salt to the water and dissolve it, it's called an unsaturated solution. What is a saturated solution then?
Equal parts.
Not equal parts. When I cannot dissolve anymore. Does that make sense? When I cannot dissolve any more salt, it's called what? It's called saturated. So then what is a supersaturated solution? What is a supersaturated solution then? What's Elias? No, it can't be that. There are super... Huh? Well, you remember, solutions are homogeneous mixtures. You can't have salt sitting in the bottom. Then it becomes heterogeneous. But how can I make a supersaturated solution? Huh?
Salt goes to like no water. It's like going over.
Have you kids ever worked with the liquid is called, this is a heating pack, like if your muscles are sore, there's a little button inside and you snap it. It's actually liquid. You snap the button and there's so much of heat that will come out and you can apply it on your muscles, but then it will solidify. Have you ever seen it? Casey has seen it, and so has Courtney. Alright? They are like heat packs. Those packets are called, they are filled with supersaturated solution. So how do you make a supersaturated solution? Let's make up a temperature. Say this is at 30 degrees Celsius. Are you with me?
Yeah.
So at 30 it's a saturated solution, right? So what do I do with the solution now? From 30, I'll probably heat it up to 80 or so. Are you with me? When I increase the temperature, what can happen? I can dissolve more salt. And then what I will do is, I will slowly cool the solution. Alright? When I slowly cool the solution, will all the salt come out? No. It will still remain in solution. But this is going to be a very unstable solution. Is that making sense? So what will happen is, if you shake the solution a little bit, or you just add one more drop of salt, like Luke was saying, all the salt will crystallize out. It will become a solid, like that heat pad. You snap it, right? Just a little bit of mechanical stress, and then it solidifies. Does that make sense? But when you cool it, it will still be a liquid. Such a solution is called a supersaturated solution. Do we understand this?
Just back and forth.
So, which one is the last one again?
Huh? The last one, say it's at 30. It's a saturated solution. I cannot dissolve any more salt. What do I do with this solution? I heat it up.
Okay, until 80.
Until 80. And then what can happen? I can dissolve more salt in it. It will still be a clear solution. And then I will cool it. It will still be a clear solution. But it's a very unstable solution. I dissolve more salt than I can dissolve at that temperature. Yes?
Can you go back up to the
What about Joel?
when the salt comes out, is it unsaturated? Or is
It's saturated. When the salt comes out, it's a solid. The salt is not. It's not working properly at all. That control is just not there. It's all there for you. I'll post it on Blackboard. Okay? Yeah. All right. Can we go back to this graph? So you will get a graph like this, guys, and you'll be asked to read this graph. It's a graph reading question. It's a skill that you practice in 9th grade. Is that right?
No.
Well, Lamin, can we put that calculator away, please? Okay. So, guys, learn to read this graph carefully. What is given on the x-axis? What is given on the x-axis? Temperature. What is given on the y-axis? Solubility. How much can dissolve in 100 grams of water? Are we good? Are we understanding?
Yeah.
Okay. Starting with Casey, I'm going to ask questions. All right? And I would like my students to follow along. Guys, it's very important you learn such graphs. Which substance is least soluble at 20? So what do I come to? 20 degrees. Which is the least among all this? Ce2SO4. Ce2SO4 3. Are we good? All right, Courtney. So this is important, guys. What is this? This is how many grams? This is how many grams of water? What does it say? 100. What is this question asking in? 200. Did you highlight that? That's 100 and this is a 200. Do we recognize the formula for potassium chloride? Which is potassium chloride? KCl. So this is the graph for KCl. Is that right? Okay. At 80. Which is 80? Is this 80?
Yeah.
All right, so how do I find out how much can dissolve at 80? Can I go up and touch KCl? And then I go across. How much do you think dissolves? 50. Is that right? Do we understand? It is 50 grams. Okay? Sam, which graph shows least change in solubility from 0 to 100, which is almost kind of flat? NaCl. Vinay, did you want to answer that question?
Number 2, wouldn't it be 100
Very good. Sorry, I am sorry. Times 2 because it's a. Oh yeah, that's important, right? I underlined it and then forget to mention it, right? This is 100, 200. 50 grams was in how much water? In 100. Therefore, in 200, it's going to be multiplied by 2. Do we get that? Lamin, are you lost or do you?
No, I like you someone out.
Okay. So, for KCl Lamin, we said at 80 it was 50 grams. Is that right? That was in how much water?
100 grams.
But they are asking in how much?
200.
So what do you do with 50?
But like 2.
Very good. Do you understand it? All right. Let's do number 4. Talia's last. So,
Lost in the song.
Talia, this is KCl, correct? This line is KCl. Are you with me? KCl, potassium chloride.
She covered it up.
This line is KCl. Okay? So they want at 80, Talia. So how much will dissolve at 80? So I climb up from 80 and I touch KCl. And then I extend across. That is 50 grams. But that 50 grams is dissolved in how much? 100. In how much do they want it? So what do you do with the 50? So that's going to be a 100 grams. Will dissolve in 200 grams of water. Okay? Now, I'm going to go down to question number 4. Well, sodium nitrate, we will give you the formula on the test. This is NaNO3. Are you with me? So guys, remember, if I have a graph, all right? Are you with me?
Yes, we are.
And,
But you like right.
all right? If there is a graph for a substance, all right? And if you get a point above the graph, it's going to be a supersaturated solution. If you get a point on the graph, it's going to be a, my graph, this thing is not aligned. If it's on the line, it's a saturated solution. If it's below the line, it's a unsaturated solution. Below is on, this is super, and that will be saturated. Are we good? Okay? We're going to answer this question. Okay? This is sodium nitrate. Where is sodium nitrate? That is NaNO3, correct? Huh? That is sodium nitrate. Everybody good? Okay. At 30, how much are you dissolving? 90. Can you get the intersection of 30 and 90? Where is the intersection of 30 and 90? So if I get the intersection of 30 and 90, is it above or below the line? This is the line. Where is the line? This is the line.
So it's unsaturated.
This is, where is the point of intersection? Is it above or below the line? Below. So what kind of a solution is this? It's an unsaturated solution. I know. But is everybody understanding it? Will you be able to answer such questions on your test?
It's going to be on the test?
Yes. Why am I doing it?
I thought we were running it for next unit.
No, we're not running it for the next unit. It's going to be on the test. Yes, Nate.
Test?
Huh? There will be a binder check too.
It's almost like writing the practice test.
Yes.
Some of these questions.
Yes. They are there. Okay. Which substance is most soluble at 10? What do you think is the answer to that question? Which substance is most soluble? NaNO3. Is that right?
I mean, I guess.
So you go to 10 and look up which is the substance that has the highest solubility. Okay?
How did you get it?
I looked at 10 and I looked at which substance has the most solubility. Everything is less than that.
Oh,
So this is the most.
Can you explain 4 again?
4, so there was at 30 and 90 the substance is sodium nitrate.
Mm-hmm.
So I look at 30,
Mm-hmm.
I look at 90 and I get the point of intersection. That is sodium nitrate.
Yeah, I saw that.
The point is below the line. If it's below the line, it is unsaturated.
Okay,
Right?
I know which line is which.
So this is sodium nitrate's line.
Yeah.
So it's below the line.
Okay.
If the point was above, then it would be supersaturated. If it were on the line, it would be saturated.
It's below the line. So.
Okay? It's below the line, therefore we circle unsaturated.
Okay.
Which substance is least soluble at 50? Okay, Ce2 SO4 Is that right? Are we good with graphing question, guys? It's just being able to read a graph. Which compound shows a decrease in solubility from 0 to 100? Instead of increasing, the graph is decreasing. Which is that substance? Yeah, Ce2, very good. Ce2 SO4 Any other substance? Any other substance which is decreasing? No. Which substance is most likely a gas and why? What happens to gases solubility as the temperature increases? The temperature will drop. The solubility will drop as the temperature increases. Have you ever experienced soda becoming flat on a hot day? Have you left soda out on a hot day?
Yeah.
Well, you should try it. You should try that. It will become flat, like all the carbon dioxide that's dissolved will all evaporate and go away. All right? Huh? It's too late for what? Why can't you? The summer is coming up. You can do it again. So many days are hot.
It's like
Even during the day,
kind of miss our chance like a couple
Not
weeks
if
ago.
it's closed, though, right?
not if it's closed. Then the pressure is maintained. Only when it's
I
open.
mean, like, it would do that in a normal temperature too. It wouldn't just.
It would take
Normal room
longer to-
temperature too, because under pressure there is carbon dioxide, right? Once you remove the pressure, the gas doesn't dissolve more, but it dissolves less with an increase in temperature.
Wait, so why did you like when you shake soda like really hard? Why is it like bubbly?
Because it's carbonated, there is a lot of pressure inside the drink, and anything that's pressured will explode. It'll try to occupy the low pressure region. It's just how things work. That's how nature works. Okay? So, which compound is most likely a gas? This compound is most likely a gas because solubility decreases with increase in temperature. Solubility decreases with increase in temperature. Are we good? Do we understand this? All right. Shall we go to the previous page? We're going to do some mole problems. This will also be on your test.
No.
I'm trying to go back. Okay, yes. Because solubility decreases as the temperature increases.
So when you said that, like, to like leave out the soda outside in a hot day, would that be the same effect if you actually microwave it?
Yeah. You wouldn't want microwave soda with a tin can. Yes, if you add it, it's going to become flat. If you heat it up, you can, yeah. Really a good thinking there. All right, good trouble. She doesn't like a hot day. She wants to heat up the drink and see if it'll become flat. Sure, by all means, try that.
Why does metal
Okay.
explode in the microwave?
Huh?
Why does
Microwave?
why does metal explode in the microwave?
It is the type of infrared rays that are given because when you heat up particles, you're actually heating up water molecules. You're increasing the speed with which they are uh, going around. So to say, you're increasing their kinetic energy. Well, metal particles are in their positions and they're vibrating. Is that right? So you probably that infrared region corresponds to gaining so much energy, and so many molecules within that metal are all gaining that energy that it kind of explodes because of the energy they gain. So you don't want that. Water has a higher specific heat. Metals have very low specific heat, something we haven't learned in this class. With very little increase in temperature, they gain a lot of energy, which water molecules don't. And so that makes a difference in how things react when they're put inside the microwave.
What about the glass?
But it has to do with the rays, not the heat.
The heat energy is also important. How much energy do they gain
So
because of the infrared rays?
theoretically-
Huh?
So theoretically, if there was like a piece of metal outside and it got somehow, well, it'd be impossible, but it got so hot,
Yeah, it could
it
explode.
could explode.
In a very short spurt of time. In a very short spurt of time, if you're focusing so much of energy on it, yes, theoretically, yes. Okay? All right. Moving on, let us do some more problems. All right? These problems will be on your test again. Have we done these kind of problems? It should be very easy to learn. What is the monkey in the middle? What do you write before a mole? Well, math, but if you're bringing down mole, what is the number that goes before a mole? Not mole, one.
Oh, one.
What is the number before atoms, molecules, or formula units?
6.02 times 10 to the 23rd.
Or formula units? How much is it? 6.02 times 10 to the 23. Where do you get the mass from?
The periodic table.
From the periodic table. So how is it now different?
There's a particle instead of
Yeah,
that.
the particles
Instead
are
of
atoms.
elements, they now have
Particles.
compounds.
Compounds.
It's not both.
Instead of elements, you now have compounds.
How are we going to tell you?
So here is potassium oxide. What is the formula for potassium oxide? We did formula writing last class.
Is it K?
Well, K, what is the charge on K? What is the charge on K? Plus 1. What is the charge on oxygen? Minus 2. So, how will I get rid of the minus 2? How much should I multiply K by? What will it multiply by? 2. 1 times 1 is 1, Abnab.
No.
2 times 1 is 2.
I was thinking about
O is a minus 2 already. So, minus 2 should balance with a plus 2. Is that correct? What is the formula for potassium oxide? K2O. What is the formula? K2O. Guys, why is everybody so slow in giving me the formulas? Next class is the test.
So,
Are we forgetting? Okay. So let's do the problem. What is given? 21.5 grams. What do I bring down? What do I cancel out of? What is grams? So what do I write here? Grams. Do I cancel out of grams? What am I converting it into?
moles.
Moles. So grams to moles is easy. Can I write moles here? Right? What do I write before a mole? before a mole?
1.
1 mole. What do I write before grams? And where will that come from? Well, it's not an element anymore. It is now a compound. So how am I going to find the mass of K2O? What do I do? Okay? So potassium, how many potassiums do you have? 2. How many oxygens do you have? 1. What do I multiply the mass of potassium by? 39 point?
Oh no!
Did we just find molar mass of compounds?
Oh, that's like,
Do we know molar mass of compounds? What is the mass of oxygen?
that's endless and endless.
16. So now what is the number? 9 into 2 is 18, right? 78. Guys, my board is not working properly.
It's too much work.
It's not too much work.
You only gave us small space to work on this.
Well, for the test, perhaps you can get notebook paper or something, all right? So let's multiply. What is this? It's 78.20. 1 times 16 is 16. What do I do with these two now? You add them up to get your molar mass. So 6, 6, 12, 13, 14, 1. Is it 94? Right? Where do I substitute this 94? Into my grams. 94.20. Now what is my math? What is my math, guys? Is it 21.5 divided by
No, times 1 divided
94.5?
by 94.
So times 1 is going to be the same number. Is that right? What is the answer? What is the answer? And how many significant figures?
Dog, oh my god.
How many significant figures? 3. Very good. What is the answer?
0.228.
0.228. What is it? What is the unit?
No,
Moles.
moles. Moles.
There you go.
All this for like 4 numbers.
Okay? Are we understanding? Okay?
You know what I mean?
Can I erase this? Well, let's do barium chloride. What is the charge on barium? Barium is a? +2. Chlorine is a? -1. What is my formula for barium chloride? BaCl2. So barium chloride is BaCl2. Okay? What am I given? 25 moles of barium chloride. Is that right? What do I bring down? The moles. What am I converting it into? Grams. What goes before mole? 1. What do I do before grams?
6 point.
Grams. Lamin, I have to do the whole calculation. All right? How many bariums? How many chlorine? What is the mass of barium from the periodic table? 137.33.
Wait, 137.
Look up barium. Is that right? Yeah. What is the mass of chlorine?
35.
Very good. 35.45. So 1 times 37.33 is 137.33. 2 times 35.45 is 70.90. Now what do I do with these two numbers?
Wait, I thought
Get your more math.
A was 2 and C on.
No, because this gets multiplied by 2,
Oh, gotcha.
right? And that's the number that shows underneath. Right? Formula writing is important. Right, 3, 9, 10, 11, 12, 1, 8, 208.
Yes.
Okay, where do I substitute this 208?
Kilograms.
To your grams.
Yeah.
208.23. Now what do I do with these two numbers?
You multiply them.
Multiply them.
Hey, man,
Yeah, you got to
Patty.
cancel by moles. Very good. Thank you, Talia. 25 times 208.23 by 1, right? That's not going to make a difference. What is the number? 5205.75. Now look at this. How many significant figures is this?
2.
2. So how do I round this to 2 significant figures? 52. What will I do with other 2 which are there before the decimal? Make them zeros. What is my unit? Grams.
Wait, should it be 52.2?
No, because this will become 0, 0. Trailing zeros don't count if the number does not have a decimal point.
So just
52 0 0. How many significant
so you
figures?
only have 2 zeros.
2.
2 significant.
So
Oh wait, Ms.Geeta, because it's 25 moles.
yes,
That's why
that's
it's
2
2.
significant
And then you didn't
figures.
put the decimal because
Yes.
it will become significant.
Yes. Let's do the next problem. 4.5 times 10 to the 24 molecules.
No.
What do I bring down?
Bring down the
Is
molecules.
this a video which is when it's recorded?
Yeah, it's a video that's recording.
Wait, is it a video of like us?
No, 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 no.
Oh,
You can just, you will just be able to see the smart code and what I write on it, and you'll be able to hear everything,
okay.
including this conversation. All right. So what do I bring down, guys? What do I bring down? What should I cancel out of? Molecules. And what goes on top? What goes on the top? Moles. What is the number before moles?
1.
What is the number before molecules? 6.02 times
What?
10 to the 23rd. And do we know how to put this number in a calculator?
You tell me we're doing
Do
all
the
these.
E thing. Instead of
Yeah, the E thing. Can we do that? And can you tell me what the answer is? I need to cancel out the molecules, right, Talia?
Yeah.
Okay, very good. And what is the answer? Are you following along? Everything is making sense?
I got
Don't lie.
7.47.
7.47. How many significant figures is this?
2.
2. So how will you round this?
Different things.
7.5 what?
Yeah.
Moles. Are we understanding these
all the-
I think
problems?
we're good. I think we're good.
All this for 2
Okay. Do you want to try?
No, we're good. No, Ms.Geeta, I think.
Ms.Geeta, I think we're good. Like, it clicked.
No, we have 10 minutes left. Is that right?
If Ali gets it, everyone gets
No, I'm going to divvy students up. Guys, that is so rude. That is absolutely rude. You cannot say such things about my students. Alright guys, this is going from grams to formula units. Can you go straight from grams to formula units? What should you convert grams into? What is the monkey in the middle? And then the mole to formula unit. Okay, now I'm going to stop this recording. I will post an answer key to this entire worksheet on Blackboard.
Yeah.
But what I want my students to do now is to work through some of these problems and show me that they can do it. Because we're not taking a quiz, but it will be on the test next class. You should know how to do it. Yes.
Is the answer key gonna have like work?
You know what I'm saying?
Yeah.
So that's
Yeah,
gonna-
yeah.
Not what you did wrong.
Yeah, it will have